Hello and welcome to Math 8, Unit 1A, Lesson 8. Today's objective is scholars will use the Pythagorean Theorem to find the distance between 2 points in the coordinate plane. So first of all, what we're going to do is try to find out how far apart are these points. And I've given you a coordinate plane and you have one in your work as well. So first we need to remember how to do this. Remember, it's always x, which is our horizontal. My x, and here's my y, and then y. So first I have the point 1, 4. So I start at the beginning, I move over 1 and up 4. So this is where my point's going to go. Right there. My second point is -3, 4. So again, I'm going to go right 3, -3, and then up 4 and put my dot right there. Well, in this case, that's pretty easy to count. So we can just count. We go 1, 2, 3, 4. And we know that this is 4 units away. Let's try these next two. So here I have -1, 2. So again, it's left 1, up 2. Here's that dot. And then I have the point -1, -3. Right there. Again, this one's pretty simple. We can just count. So I count, I go 1. Remember, we don't start with 1 here. We go 1, 2, 3, 4, 5. Nice and easy. So this one is 5 units away. Well, what if they are not on the same line? So here I have the points 1, 3, which is over 1, up 3 right here, and -3, -1. So I go left 3 and then down 1. In this case, we can't just count over, but we do have the ability to sort of create a triangle. So I'm going to sort of highlight these lines so you can see my triangle. So I've just made a right triangle in which side C is the distance between the 2 points. Here's A and B. Well, we can use the Pythagorean Theorem now to find the distance between these 2 points. So again, I'm going to use A squared plus B squared equals C squared. So when I count how long side A is, I count and get 1, 2, 3, 4. So side A is 4 units. Side B is 1, 2, 3, 4. So side B is also 4 units. So I have 4 squared plus 4 squared equals C squared. So I have 16 plus 16 equals C squared. So 32 equals C squared. Remember, the distance isn't 32, though. I have to take the square root of both sides. So the exact distance is going to be the square root of 32. But again, not really sure exactly what that is. Somewhere between 5 and 6. So when I put that into my calculator, I put the square root of 32 in there. It gives me, rounded to the nearest hundredth, I get 5.66, because it's actually 5.656. And remember that number next to it tells me to go up. So it's approximately equal to C. So that's rounded to my nearest hundredth. So let's try that again. Here, I'm between the point 0, 4, which is right here. Remember, the most important part here is make sure you get your placement right. And 4, -2. So again, we can make our right triangle. I go down until I get to the, down or up until I get to the next arrow, over, and that's my right triangle. So this side, this bottom side is 4. This side is 6. So I have my A squared plus B squared equals C squared. Remember, we always start with that. So I have 4 squared plus 6 squared equals C squared. 16 plus 36 equals c squared. 52 equals c squared. And then we take the square roots of both sides. So my exact answer is the square root of 52. But remember, we want to give an approximate answer as well. So that is 7.21 is approximately equal to c. Again, you're doing that on your calculator. Let's try another one. So, it's a different color. Here I have the point negative 1, 1, which is right here. And I have the point 4, negative 4, which is right here. Again, I'm just going to draw my triangle and count how long my sides are. So this side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4, 5. So I have a squared plus b squared equals c squared. 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. So I know the square root of 50 is my exact answer. And if I put that in my calculator, I get approximately 7.07 is approximately equal to c. Okay, one last example. I'm going to show you a different way to do this if you want. So this is the distance formula. We use our two x values. We find the difference between them and square it. And then we do the same thing with our y values. We find the distance between them and square it. So here's x1 and y1. Ooh, wow, those don't even look like y's, do they? And y1. And here's x2 and y2. So I'm going to take the square root of x1, which is negative 10, minus negative 5. Remember, minus negatives turn into positive. And we're going to square that. Then we add y1, which is 5. That does not look like a 5. Let's try what looks like a 5. Minus 7 squared, and we take the square root. So negative 1 plus 5 gives me negative 5. So I have the square root of negative 5 squared plus negative 2 squared. So I have the square root of 25 plus 4, which is the square root of 29. If I put that in my calculator, square root of 29 is 5.39. Okay, and let's try the second one. We're going to do the square root of x minus x. So we have 4 minus negative 3 squared plus negative 8 minus 2 squared. So 4 minus negative 3 turns into 4 plus 3. So I have the square root of 7 squared plus the square root of, or plus negative 10 squared. So I have the square root of 49 plus 100, which gives me the square root of 149, which if I put it into my calculator, I get 12.21. So that's another option if you want to. All you do is x minus x squared plus y minus y squared, and then take the square root of the answer. Okay, so either way you can do it. Go ahead, and I want you to try some problems on your own, and I will see you in class.